Hello, this is the first video of the Critical Path Analysis Series 2 on Cascade Charts and Scheduling. It will show you how to construct a Cascade chart. In the previous CPA series, we considered how to construct a completed activity network, such as the example given here. Note that the project minimum completion time is given here and happens to be 20 units of time, and that any delays to activities on the critical path ADF, as shown in red, will delay the project completion. You should also remember that we introduced the idea of floats on non-critical activities in the first series, and that these activities, for example E, can be delayed without impact on the whole project completion time. So let's focus in on that activity E. Float is the spare time associated with an activity, and it allows some flexibility in terms of scheduling, which will be discussed in a later video. So the total float for an activity is the latest finish, given here, minus the earliest start, minus the duration of the activity, which you remember will be given in brackets as the weight on the arc. Activities with zero float are critical activities, and vice versa, and every project has at least one critical path. When managing a project in the real world, for example a large building project, the use of Cascade, or sometimes known as Gantt charts, are really important tools and used extensively. Software is available to create and use these. So a Cascade chart is a way of illustrating how activities can be scheduled on a timeline relative to each other. It summarizes the information available on the activity network with earliest start times and finish times and float, as well as showing the critical activities. So it is just another way of communicating all that information in the network, but also has the advantage of determining what resources are really required, whether they are people or equipment, and whether delay or other changes can be accommodated within the project constraints. For example, there might be a large financial penalty for late completion of a project. So to set up the Cascade chart, we would establish a timeline where the time is in whatever units is given in the context of a question. So here we've set up the units from 1 to 20, with 20 being the completion time given in that particular example. To place an activity, for example E, on the timeline, look at the start time, the earliest start time being 4, and usually we would use those early start times unless directed otherwise in the question. And we look at the duration, and for this it's E, it's 13. So we would block out 13 blocks of time for E, and then the float, which in this case remember we knew was 1 because it was 18 minus 4 minus 13 gave us that float of 1, could be shown using a dotted line. So we would start with looking at the critical activities. In this case, I will show you that we placed them all on one line. They don't have to be, they could be placed on separate lines. But generally speaking, critical activities can be placed one after the other because they form the critical path. The other activities must be shown in their own row. So starting at the earliest time of 0, A would take a block of 6, duration 6, then immediately D would start and take a block of 10, and then followed by F, which takes that last block of 4. So that's your critical activities. I'd probably then leave a row, if you have room, and show B starting at 0 and lasting 4. Then C, again earliest start time 0 and lasting 15, and so on. So here we have placed the critical activities first and placed the other activities. Now I need to show the float for the non-critical activities. For B, this would be 5 minus 0 minus 4 equal to 1. For C, it would be 20 minus 0 minus 15, or 5. For E, 18 minus 4 minus 13 equal to 1. And for G, 20 minus 17 minus 2 equals 1 also. So the use of the dotted lines can be viewed as the flexible space into which we could slide the activities along should we need to try and deconflict them in any way. And this is a good visual representation of how to use the floats. Thus, the Cascade or Gantt chart gives us an advantage compared with trying to interpret the activity network. If we're asked to construct a Cascade chart for this activity network, key things to notice are the completion time and the critical activities. In this example, there are 2 critical paths, which happen to be A, C, F, H and J, or A, C, G, J. Thus the critical activities are A, C, F, G, H and J. We would set up our timeline placing the critical activities on the top row, where there are 2 options. We will show these in parallel. And then we will start placing the other activities below. And then working out the floats as we did before. Note that the use of the dummies in this activity network does not influence the way we work out the floats. So, for example, with L, we would still be looking at 21 minus 14 minus 3 to give us that float of 4. In the next video, we will look at using a cascade chart to help us make some decisions.